Welcome to the deep dive. Okay, so you've sent us a fascinating pile of sources on genetically modified organisms, GMOs. Definitely a topic that gets people talking.
It certainly does. A lot of strong opinions out there.
Exactly. So, our mission today is really to cut through that noise. Let's unpack the science based on these sources and see what they actually say about the health side of things.
Sounds good. Because there's often a gap, isn't there, between the public chat and the scientific findings.
Totally. Let's dive into what the research and the experts in these documents are telling us about GMOs and, well, your health.
Okay, well, the first thing that just jumps out from pretty much all the scientific sources is this really strong consensus.
Consensus. How strong are we talking?
We're talking overwhelming, hundreds of studies backed by something like 280 food safety agencies across the globe.
Wow, 280.
Yeah. And these aren't small names. Think the US FDA, the European Food Safety Authority, the World Health Organization. They're all pretty much aligned.
Aligned on what specifically?
That the GMOs currently on the market are safe to eat. It's not just a maybe. It's a really robust scientific agreement based on decades of evidence.
Okay, that's a big statement. What underpins that confidence? Is it just the sheer number of studies, or is there something about how they're tested?
Both, really. The sources highlight that these GMO products often go through way more rigorous testing than, say, conventional crops before they ever hit the shelves.
More rigorous. How so?
Well, we're looking at an average of something like 16 and a half years.
16 years.
Yeah, and about $115 million spent on research and getting through all the regulatory hoops for each product.
That's a massive investment in time and money.
It really is. And crucially, after all that, decades now, of people actually eating these foods haven't shown any link, no difference in major health issues like cancer rates or allergies tied specifically back to the GMOs themselves.
Okay, so the safety aspect seems quite solid based on these sources, but they also talk about more than just safety, right? There's this idea of positive health impacts.
Exactly. That's a really key point. Beyond just being safe, the technology itself can be used for some pretty significant health benefits through something called biofortification.
Biofortification. Break that down for us.
Sure. Think of it like enhancing the nutritional value of basic food crops. It's a way to fight hidden hunger, those widespread vitamin and mineral deficiencies that affect millions, even if they're getting enough calories.
So boosting the good stuff in everyday foods.
Precisely. And what's amazing is how targeted it can be. The classic example is golden rice.
Ah, yes, I've read about that. Engineered for vitamin A.
That's the one. Designed specifically to combat vitamin A deficiency, which is a major cause of childhood blindness, and also contributes to things like diarrhea in young kids in certain parts of the world.
So it's not just food, it's almost like a public health tool.
Exactly. Or you've got things like iron-enriched beans being developed, which studies show can help reverse iron deficiency. That has knock-on effects for cognitive function, energy levels.
And you mentioned potatoes, too. Something about acrylamide.
Right, the innate potato. It's
Yeah.
engineered to produce less acrylamide when it's fried.
And acrylamide that's the stuff in burnt toast, the suspected carcinogen.
That's the one. So the idea is to potentially reduce your exposure to it when you eat things like fries or chips. So, yes, it positions GMOs not just as an agricultural thing, but potentially as a direct public health intervention.
Okay, that's compelling. But, no deep dive is really complete if we don't look at the concerns, too. Even with this positive data, what lingering questions or areas for caution do these sources point out?
That's fair. And the sources do acknowledge some areas. For instance, there's this theoretical risk concerning antibiotic resistance genes.
How does that work?
Well, sometimes these genes are used as markers during the development process. The concern is whether they could potentially transfer from the GMO food to bacteria in our gut.
And make those bacteria resistant to antibiotics.
That's the theoretical worry. Now, regulatory bodies look at this closely and generally characterize the risk as very small.
But not zero.
Not absolutely zero, which is why they emphasize continued monitoring. And it influences development practices, like trying to avoid using marker genes linked to clinically important antibiotics.
Makes sense. Anything else?
Well, despite all the observational data showing no harm over decades, some scientists highlighted in the sources still argue for more specific long-term human epidemiological studies. Just be absolutely thorough.
Right. Ongoing vigilance. And what about the rules, the regulations? Are they settled?
Not entirely, and that's another layer. Your sources mention Canada, for example, where there's been some debate.
What's happening there?
The regulatory approach is shifting, and some newer gene-edited plants, might not need the same mandatory government safety assessment if the developer deems them not novel enough.
So the company decides if it needs the government check.
In some cases, potentially yes. And that, understandably, has sparked discussion about transparency and who ultimately ensures safety. It really highlights that public trust isn't just about the scientific data, it's also about feeling confident in the regulatory process itself.
Which brings us back kind of full circle to that gap you mentioned earlier, the gap between the scientific consensus and public perception.
Exactly. The sources point out that people's concerns aren't always just about health safety. They could be tangled up with environmental worries, economic impacts, social justice questions, and all that feeds into why certain myths persist.
Right, like the it's unnatural argument.
Yeah, which kind of ignores the fact that humans have been unnaturally modifying crops and animals for thousands of years through selective breeding. We've fundamentally altered their genetics already.
Or the idea that it's all just a scheme to sell more pesticides.
When actually, some of the major GMO crops were designed to reduce pesticide use. And studies, like one cited in your materials, show they've led to quite a significant drop, like 37% less chemical pesticide use overall for adopters.
So the facts don't always seem to cut through the noise.
It seems not. Clearly, just presenting the data isn't always enough to shift deeply held views or address those wider concerns.
Okay, so wrapping this up, what's the big picture for you, the listener, from this deep dive into these sources?
Well, I think the sources paint a clear picture of strong scientific agreement on the safety of the GMOs we currently eat.
And potential for real nutritional benefits, like with that biofortification.
Definitely. Significant potential there. But there's also this crucial challenge
Which is?
that realizing the benefits of these technologies moving forward isn't just about the science working. It's hugely dependent on how well we communicate this complex stuff, how trust is built or rebuilt, and how genuinely societal concerns are heard and addressed.
So perhaps the biggest takeaway isn't just about the GMOs themselves. Maybe it's more about that whole ongoing, sometimes difficult conversation between science, society, and how we perceive risk and benefit.
I think that's a great way to put it. That conversation is really what shapes how we use these powerful technologies, for better or worse.
Something definitely worth thinking about.